Hello students, welcome back to the series. See, today the question paper, the practice paper which would have got was the paper based on the advanced level. Okay, so now today of course we are going to discuss a solution. See, answer is not my concern. Okay, so if those who want to match the answer should complete the solution which I am going to discuss till the last step. Okay, it may happen that in few cases I might solve the questions completely, but in rest where I feel that that the calculation is going to be very lengthy, I may skip it and then ask you people to complete it. So that's it. So chaliye, let's continue with the series. I believe you people must be solving the questions before watching this video as solutions. Okay, so because then only it's going to be helpful. Bachcho, chaliye, let's start. So the first question is the graph of this. The graph of y square plus 2xy plus 40 times mod x is equal to 400 divides the plane into two regions. Of course, which plane? The xy plane. It's a curve on xy plane only. The area of bounded region is, so see, that's a question. Now you may feel that it might be a question of integration. Of course not. I got it this question as a question of straight line, so I just like presented it in front of you. See, let's draw it. So what will you do? You will say, okay, y square plus 2xy. See, that's how I tried to do it. Plus x square. I got it as perfect square. Okay, and then take it that side. So it's like 400 plus x square plus minus 40 times mod x. So of course there are two possibilities, because whenever we have to get rid of mod x, we have to consider two cases here. So what are those cases? So mod x, of course we know, is x when x is greater than equal to 0, and this is minus x when x is less than 0. So that's your mod x here. Now put the value. So y, so this is perfect square, so y plus x whole square, and this is what? So it is x square minus 40x, and then and then plus 400. So for what are we solving? We are solving when I am considering x to be greater than equal to 0. Now let's see what does this represent. So what does it represent? So we get here y plus x as either x minus 20, that's one case, or minus times x minus 20, that's the second case, because on both the sides you have perfect square. When you remove square, we put plus minus sign. Okay, so what are those cases? So let's try to plot it. Okay, so first one is y plus x is equal, so x gets cancelled, y is equal to minus 20, and remember x is positive, so y is equal to minus 20, x is positive, so that's the line. Y is equal to minus 20 on the positive side of x, on the right side of y-axis. Okay, now let's move to the second case. So this one, what does that give us? So if I write it here, so it's 2x, so 2x plus y is equal to 20. Okay, so y is equal to 20 and x is equal to 10. So y is equal to 20 and x is equal to 10. So that's the line again. So of course, since it's again for positive x, so that's it. That's it. Okay, so we won't extend it beyond the y-axis. Now let's move to the second possibility. Second possibility is when x is less than 0. Okay, so in that case I'll be replacing mod x by minus x. So what will we get? We will get y plus x. So when x is less than 0, so what will we get? We will get y plus x is a whole square. That's unchanged without any, like, it has no dependence on x less than 0 or greater than 0, but here you will get as x plus 20 whole square. So what does that give us? So this gives us y plus x is equal to either x plus 20 or it is equal to minus times x plus 20, isn't that? So now again, so what are the possibilities? So when x is less than 0, y is 20, so that's the point. So this is y is equal to 20, and then this is x, y plus 2x is equal to minus 20. So y is minus 20 and x is minus 10, so that's it. Which figure is it? So isn't that a parallelogram? So that's a parallelogram. We need its area, that's the bounded region. We need its area. So what is it? So half base into height, so this is 40, and base length is, so you have to just find this length here, isn't that? So now, sorry, not half base, it's base into height. Okay, so you have to just find this, and for that you have to find this point of intersection, get it, and you get the answer. Okay, so that was an interesting question based on this analysis, so that's why I picked it up. And now moving to the next question, bachcho. Second question is three families of lines. See, we know in general L1 plus lambda L2 is the equation of family of lines, and it represents those lines which pass through the point of intersection of two given lines L1 and L2. So all lines that pass through the point of intersection of two given lines which are L1 and L2. So see, that's the case here. So that's one line. So 2x plus 3y plus 1 equal to 0, and this is 2x plus 4y plus 4 equal to 0. Fine. So now what? See, we will get the point of intersection. We will get the point of intersection. So this first one, this is the family of lines passing through the point of intersection of these two. So if you just solve it, we get it as minus y, and then it's minus 3 equal to 0. So y is equal to minus 3. Isn't that, bacho? So put it here. So y is equal to minus 3. So 2x is equal to 8 and x is equal to 4. So we got first point. Let's say this is 4 comma minus 3 through which all lines of this family pass. Now moving to the next one. Next one here, see here, of course the parameter is tan theta. Okay, so the parameter is tan theta, unknown constant is tan theta. So let's collect the term likewise. So we will say, so it's 3x plus 4y plus 4. Instead of lambda you have tan theta, and then it's 6x plus 4y plus 1 equal to 0. So again, this represents all possible lines that pass through the point of intersection of these two lines. So it is 3x. So if we solve it here itself, so it's 6x plus 8y plus 8 equal to 0, and this is minus 6x minus 4y minus 1 equal to 0, and then that's it. So it's 4y plus 7 equal to 0. So y is equal to minus 7 by 4, and then you put the value here. I mean maybe here. So 7 minus 7 by 4, so it's minus 7 6. I think 6x is 1 if I'm not wrong. Okay, so let's say another point is 1 comma minus 7 by 4. Okay, now next, find the value of lambda so that three families have a common member. Three families have a common member. Now what does that mean? Okay, so that simply means, now see, that's again a family of lines. Equation of or possible family of line. Okay, now see, if these two have a common member, that means it represents, the first one represents all lines passing to this point, second one represents all lines passing to this point. So if those two family of members are like, if those two families have a common member, that means we need to have a line which passes through these 2 points, yes or no? So of course if I say that's the point, so that's the point, that's the line. Now if all three have a common member, that means get this line using 2-point form of equation of line. Using 2-point form of equation of line, get this line, bachcho. After getting this line, put the value here. Okay, compare it with this one. You need to compare it with this one. Okay, and then you get the equation of line or the value of lambda here. Or what else you can do is, you can just again solve these two, x plus y plus lambda equal to 0. See what the first thing I said? The first thing I said was, you get this line, of course you get it in the x, y, and then compare. So if two equations represent the same line, how do we compare? We use similarity condition. The ratio, the corresponding ratio of the same coefficient, like the coefficient of x, the coefficient of y, their ratio is equal to the ratio of constant. And then you solve it, will get k, you will get lambda, and hence the answer. Okay. Otherwise what you can do is, of course you can solve these two equations and then get the point through which this pass. Okay, and then satisfy that point in the equation of this line. Of course that point has to be on this line, and that's it. Okay, so that's it. So this is how you can solve it and you will get the answer. So now moving to the next one, distance between the pair of parallel straight lines. See whether it's given or not given. Let me tell you all, bachcho, ax square plus 2hxy plus by square plus dot equal to 0. If at all it represents equation of pair of straight line. And what does it represent? When delta is 0. We all know it, isn't it? So if at all it represents equation of pair of straight lines, then it will represent pair of parallel lines only when h square is equal to ab. What does that mean? That means only and only when the second degree terms form a perfect square. Okay, form a perfect square. So that should be the case, and that is the case. So it is nothing but x plus root 2 y whole square. So if second degree term form a perfect square, there are just two possibilities. Either it's going to be a parabola or it's going to be the equation of pair of straight line. Parallel pair of straight lines. Okay, so these are the two possibilities. How will you verify it? With the help of this delta 0. So it's the case which we are seeing here. Delta not equal 0, it will be the equation of parabola. Okay, so that's it. Now see which two lines are there in that case. So that represents the equation of pair of parallel lines. So the lines are like this one, and the second one will be, so in both the lines the x and y term that remains exactly same, bachcho, and that's it. Okay, now the distance between two parallel lines. So what's the formula? So formula is mod of c1 minus c2 upon under root of a square plus b square, which is 3, isn't that? So we have to just get c1 and c2. How will you get that? See, in that case, just multiply these two. We know how do we get combined equation of pair of straight line? We get combined equation of pair of straight line by multiplying the two individual equations having 0 on in RHS in both the equations. Okay, so just multiply them, and see, we don't have to multiply them till the end. We have to just get two relations involving c1 and c2. So the first one is quite clear. When you multiply them, so c1 c2, and you compare it with this one, so that is 1. Another one can be you multiply with x, so a coefficient of x, so it will be c1 plus c2. When you multiply these two, and the coefficient of x is 4, so that's it. What do you need? We need c1 minus c2, so you can get it here from here. So c1 minus c2 whole square is c1 plus c2 whole square minus 4 c1 c2. Put the value under root, because we already need mod, so whatever you get has to be positive. I mean, that's what we need, positive number. So just put the value here and you have the answer. Okay, so the importance of question lies in this part, whatever we discussed here. And then how to get the unknown here. There are two unknown only, c1 and c2. You can easily multiply these two equations and compare it with directly to get the relation involving c1 c2 and c1 plus c2. So that's it. Moving to the fourth question. Fourth question is, two sides of a rhombus lying entirely in first quadrant or fourth quadrant of area equal to 2 square units are this and this. Okay, then possible coordinates of B is or are O being the origin. Okay, O, A, B, C. Right. See, y is equal to x by root 3. Y is equal to root 3x. Now angle. So x by root 3, we know, and slope is 1 by root 3. Tan theta is 30 degree. Root 3x, this angle is 60 degree. What does that mean? The angle between these two is just 30 degree, right? Okay, it's a rhombus. We are going to have a rhombus. So let's say something like this. Okay, so this is parallel to this one, and this one is parallel to this one. So let's say that's the rhombus. Now see, in the rhombus we know that the diagonal are the angle bisectors also. In rhombus we know that diagonals are perpendicular to each other. These are two information which we should remember. See, these geometrical properties of quadrilateral, of circle, they are really very important. Okay, in mathematics, till you have mathematics, you need to remember them. Now it's an angle bisector, so of course that line is y is equal to x line. We all know it. Okay, so that's the point which we need. So O, A, B, C. So that's the point we need. Let's say this point is P comma P. That's it. Area. How will we get that area? See, what we can do is, so it is perpendicular to this one, and then see, we can easily get it. So let's say OA. This length is nothing but A unit. I mean, not till here. So this is A, the side length of a rhombus. So area of this triangle. So half A into A, OA into OC into sine theta into sine 30 degree. Okay, so how much is it? So half A square, sine theta is half, and then this is equal to 2. So A square is 8. So A is 2 root 2. We got it. Okay. Now, if I have to get this length, because that's the vertex we need. Okay. I'm sorry. This is area of the triangle. We need area of the rhombus. So I need to just multiply it by 2. So 2 gets cancelled. I'm sorry, A square is not 8 actually. A square is 4. Right. So A square is 4. So A is 2. So A is 2 here. Right. Okay. Now see, we need this length. Now I will apply the cosine rule. Why? Because see, if this angle is 30, then this angle is nothing but 150 degree. So because once I have OP, I have the result. I mean, I have P. That's what we need. We need coordinates of P here. So this is cos 150 degree. Applying cosine rule, bachcho. Cos 150 degree is, Sum of square of adjacent sides, which is a square plus a square, 4 square plus 4, 4 plus 4 is 8, isn't that? Minus the third one, which is OB square upon 2 into OA into AB. So it's again 2 into 2. Okay, so cos 150 degree is same as what? Minus root 3 by 2. So minus root 3 by 2 is equal to 8 minus OB square upon 8. So this is 4. So OB square is 8 minus 4 root 3. Oh my god. Okay. I think that's what we have. Isn't that? Just a minute. 8 plus 4 root 3. No? Bachon. This is minus. Right. 8 plus 4 root 3. Right. So now OB square is nothing but 2p square. P square plus p square, 2p square. So 2p square, and we need p, don't forget, we need p. So it's 8 plus 4 root 3. So p square is 4 plus root 3. Okay, so p is under root of 4 plus root 3. Okay, so that's it, I think. What else? Okay, 4 plus 2 root 3. Okay, then it's done. So it's root 3 plus 1. That's it. So the coordinates are root 3 plus 1 comma root 3 plus 1. So coordinates are root 3 plus 1 comma root 3 plus 1. So that should be the answer. I think you people got it. So I just used like the geometry part of the rhombus, the cosine rule, and nothing else. And yes, see, I got it. Again, I will say the geometry part of the rhombus. Okay, diagonals in rhombus are angle bisector of the vertex angle, and they are perpendicular to each other. That's it. So moving to the fifth question. Fifth question is, let point this with the vertices of the triangle ABC. I is the triangle in center of triangle ABC. See, this is the question which I take it more as a question of geometry, as a question of maybe a bit of trigonometry. But let's do it, because that's a question which I solved without using any vertex information. Okay. A, B, and C. I didn't use anything related to straight line like equation, although we can use it. Okay, but then you can try to use it. There's an in circle that touches AB, AC. Let's say this is at D, this is at E. The in center somewhere here is the, let's say that's your in center. Okay, then join the vertex, wait, I is the answer. E and D are the points of contact of in circle with AC and BC. AC and BC. So that's D. Okay, that's D here, right? Next is if G is the intersection point of angle bisector of angle B and a line joining ED. Line joining ED and the angle, see, angle bisector. What is I? The in center. In center is the point of concurrency of all the angle bisectors. So of course, the angle bisector of B will pass through I. Let's say this is G here. Fine. Now let us complete it. So if I join this, we know geometrically this is perpendicular to the side. If I join this is perpendicular to the side, and this angle is also 90. Of course, this angle is also 90 degree, right? Now, of course, this is angle C. Know it? Now, CD is equal to C. Tangents are of equal length, form external point. CD is equal to C. Just a minute, let me get them here. Right. So CD is equal to CE, so these two are equal, hence these angles are equal. So how much is this angle? So sum of the angle in a triangle is 180, so C gone, 180 minus C, half is 90 minus C by 2. So this is 90 minus C by 2, hence this angle is also 90 degree minus C by 2. Now how much is this angle and this angle? They are C by 2 and C by 2. Okay, angle IED is equal to angle IDE, because again these are isosceles triangle. This is also and that one also. Okay, so that's what we got. Now if I join A and I, so again that has to be the angle bisector, isn't that? So this is A by 2, this is again A by 2, this is of course B by 2. So how much is this angle, bachcho? Again, using angle sum property, so this angle is nothing, 180 degree minus A by 2 plus B by 2. But we know a by 2 plus b by 2 plus c by 2 is nothing but 90 degree. So 180 minus this means this is 90, and then 180 minus c by 2. Fair enough? Okay. So this is 90 minus c by 2. What does that mean? That means this angle, which angle? AIG. Angle AIG. Since it's a straight line, BG is a straight line, so angle sum, it has to be 180. They are supplementary angles. So 90 minus c by 2. So this is 90 plus c by 2. Okay. Now look at it carefully. Look at this one. So let me try it using some other color. Which color shall I use? Maybe this one. AIGE. This one. So AIGE is a quadrilateral. Of course, it's a quadrilateral. In which angle I plus angle E. Now look at this angle. So again, let me mark it with some other different color. This angle. That was 90. Angle AEI and angle IEG is c by 2. So this angle is 90 plus c by 2. So angle in this quadrilateral AIGE, angle E plus angle I, angle E plus angle I. How much is it? So it's 90 plus c by 2. 90 minus c by 2, so it's 180 degree. That means the sum of opposite angle in a quadrilateral is 180 degree. That means what? That means that the quadrilateral is a cyclic quadrilateral. So that's a cyclic quadrilateral. So that means you have a circle passing through these three vertices. Look, doesn't look like a circle, but see, it has to be a circle. Now see, now that simply means that sum of, see, this is angle. We need AG and BG. Wait, we need AG. So I have to AG. Okay. Right. See, now consider IG to be a chord of circle that I do here. Okay, this white circle. IG is the chord. So this implies, we know the theorem. Chord subtend same angle on the same arc of the circle. So IG is subtending angle A. So therefore angle IAG is equal to angle IG is subtending angle at E also IEG. And this is nothing but c by 2. So this angle is c by 2. This angle is c by 2. So this is c by 2. Now we need angle between BG and AG. So we need this angle. That's it. We need this angle only. Okay, so how will we get it? So we will get it. Now consider the triangle BGA. In triangle BGA, of course, B by 2 plus this is A by 2 plus C by 2. Okay, plus angle AGI is 180 degree. And we know A by 2 plus B by 2 plus C by 2 is 90. So hence angle AGI is 90 degree. See, only those students I know will be able to understand who will follow this video step by step. Just by looking at it, it might be a bit confusing. See, I didn't change it quite often because see, then it will take a lot of time to go back and then see where I have written what. Okay, so that's why I tried to solve it in just 1 or 2 slides. Okay, but then that's the question which I solved with the help of geometry only. I didn't use any equation of straight line, any vertex, nothing means nothing. Okay, so you can definitely try to use them using writing the equation of lines and all those things, and then you may try to get the answer. If the coordinates of the curve subtends angle at the radians at the point 1, 1, then the value of KC. Now, the purpose of taking up this question is homogenization. So, when do we use homogenization? When there is a curve and there is a line which form chord with the curve, and then the chord subtends some angle at the origin. That's what I always say. Angle subtended by chord of the curve at the origin implies homogenization. But here the point is not origin. The point at which the chord is subtending angle is 1, 1. So how to use it? We will use it by shifting the origin. Okay, so we will shift the origin, and what am I going to do? See, what will I do? So that's our original XY plane, whose of course origin is 0, 0. Now where do we want to shift the origin? The point where the chord is subtending the angle. So I will call it as capital X, capital Y. This point is 1, 1. So if that's the point P in terms of small x and y, and I want to write it in terms of capital X and capital Y, where's the relation? So the relation lie here. This is the length, which is small x. So x is equal to, this is how much, bacho? This is 1 of course, and this is our capital X, yes or no? That's our capital X. Distance of the point from the y-axis is the abscissa of the point. So that's the capital X. So this is 1 plus capital X. So x will be replaced with 1 plus capital X. Similarly y, this is our y. Okay, and here again y is nothing but this is our 1 and that's our capital Y. So it's 1 plus y. So wherever you have a small x, a small y, so I will do it here itself. So it's capital X plus 1 plus 2 times capital Y plus 2 minus 2 equal to 0. So it's capital X plus 2 capital Y is equal to minus 1. So we know, see, when we have to homogenize, we know we need equation of line in the form where you have 1 as a constant in RHS, so minus x minus 2 times capital Y is equal to 1. So that's what we will be using. Now changing this one also, so I will do it again, do it here itself. X plus 1 whole square plus y plus 1 whole square minus 8 times x plus 1 plus 2 times y plus 1 equal to 0. Let's simplify. So 6x square plus y square, this is 12x minus 8x is 4x, 2y plus 2y is 4y, and minus 8, 6, 7, 1, 2 plus 1 if I am not wrong. Okay, now to homogenize, what are we going to do? So we'll rewrite the equation of curve 6x square plus, I think it was y square, 4y, 4x, it's 4x. Let me check it, 12x minus 8x, 4x. Plus 4y plus 1, okay. Y square plus 4x plus 4y plus 1 equal to 0. So now how do we homogenize? So to homogenize, we don't disturb the second degree term, but multiply first degree term by 1, and this is 1 square, constant by 1 square. Now wherever you have 1, you will be replacing it with this one in the line, and this is minus x minus 2y. 6 times minus, oh sorry, that's the same thing, I'm really sorry, we don't have to do anything here. So 6 times x square plus y square plus 4 times x, 1 to be replaced by minus x minus 2y, 1 to be replaced by minus x minus 2y, 1 to be replaced by minus x minus 2y whole square equal to 0. Now collect the terms, bachcho. So collect terms of x square, what is it? 6 minus 4 is 2 and then 1, so it's 3. Isn't that 6 plus 1, 7 minus 4. Now for y square, 1 and then this is minus 8 plus 4, 5. Okay, we got it. See, we don't need after this, if you remember. See, angle between two lines. See, first of all, what does this represent? This equation represents combined equation of the line. So this equation represents combined equation of these two lines joining the endpoints with the origin. Okay, after homogenization, that's what it represents. So if we need this angle, we know this angle is theta, then tan theta is 2 times under root of h square minus ab upon a plus b, where a is coefficient of x, b is coefficient, a is coefficient of x square, b is coefficient of y square, and capital H is half times coefficient of x into y. But then since a plus b is 0 here, coefficient of x square and y square sum is 0. What does that mean? That means lines are perpendicular, because a plus b equal to 0 means it's undefined, so that means theta is pi by 2. So the angle subtended by this chord at 1, 1 is pi by 2. It's pi by k, so k has to be 2 here. So that's the first question, I think, where I got the answer. I solved it completely. Okay, now a triangle ABC with vertex this and this inscribed on the curve. See, I got this question, I mean, as a doubt, but then I didn't solve it. I use it nowhere. I don't know why have they given. If anyone else while watching this video get the idea, do let me know. Because see, how I use it, that you will definitely come to know. After that, I didn't find any purpose of this form. H alpha is the orthocenter let DEF with the feet of perpendicular form ABC on the opposite sides. In radius of triangle DF is our then. See, let's say wait, 2 5 5 2 is 2 comma 5. See, I have already discussed such type of thing earlier also. You look at these 2 points. Aren't they the mirror image on the line y is equal to x? Of course, yes. Third is C, which is minus 1 comma minus 1. So that's the point on y is equal to x. So that means this y is equal to x line is the line of symmetry, and this triangle is nothing but an isosceles triangle for sure. Okay, and this is perpendicular bisector. Again, I am repeating, these are the mirror images of each other on the line y is equal to x, and the third vertex minus 1 lie on it. So of course, and this is the perpendicular bisector. See, for an isosceles triangle, the line or the median passing through the common vertex of equal side is the perpendicular bisector of the opposite side, is the angle bisector of the common vertex, is the like altitude for the common vertex, everything the same line. So that means orthocenter should lie on it. So but for orthocenter, this is 1. So that's the orthocenter, and alpha comma alpha, I don't know why have they given it, because it has to be in any case alpha comma alpha. So that's it. So see what I did, we have the slope. Achha, while solving it, one thing I found, bacho, I will share it with you. D, E and F, if I am not wrong, B, C, A, B, yeah, D, F. See, while solving it, I proved something. I mean, it's not like I proved something new, but D and E is parallel to AB. That should be true for any isosceles triangle. Okay, what does that mean? If you join the foot of normal, the feet of normal on lying on 2 equal sides, and then that line segment will be parallel to the third side, the unequal side of the triangle. Okay, I proved it. Let me see yeah, using congruency I did it, bacho. I did it with the help of congruency here. So you may do it like I considered this triangle and this triangle. Okay, these two sides are equal, so this complete angle is equal, so this is 90, this is 90, and one side is common, so these two triangles are equal. So these two triangles are equal, and then I used something else also. So yes. Then I said since these two triangles are congruent, then they have same area, and both the triangles have same base. So then we come to the theorem that two triangles lying on the same base, on the same side of the base with equal area, the opposite vertex lie on a line which is parallel to the base. Hence I proved that DE is parallel to AB. Now what is slope? Because it is perpendicular to y is equal to x, so this has to be x plus y is equal to something. Of course this is 7, 2 comma 5, 5 comma 2, so 5 plus 2 is 7, so x plus y is equal to 7 is that equation. So one thing is for sure, that its equation has to be in terms of x plus y is equal to something, but then I have to stop because I have to find that something, because I know there's one option in terms of x plus y minus 13 by 5, you have to solve it. So then see, I mean you may say that what's the use, just I'm discussing what I found or how I approach or how whatever I did while solving this question, bacho. Okay, so now next is I just try to get its slope. So this is 3 by 6, so it's half. Okay, so this slope is minus 2. So just write the equation of line passing through this and with the slope. So it's this line is y minus 5 is equal to minus 2 times x minus 2. So 2x plus y is equal to 1 if I am not wrong. Now just solve and see, this is your orthocenter. So solve it, y is equal to x. So satisfy this point x comma x here. So this point is nothing but 1 by 3 comma 1 by 3. So orthocenter is 1 by 3 comma. See, this option is highly, irrelevant, because any vertex can be the orthocenter only when at that vertex the triangle is a right angle triangle. That's the only possibility. Okay, so that's not the case here. Fine. So that's it. So now see, now what I did, so we have to find this point in that case. For that's what I did, bacho. Okay, so when I solved this, I solved this equation of line with this line. So I have to write this equation. I found this point, then of course we know its slope, and we have this equation that didn't match. Now let's come to the in radius. For that I just completed. So let me draw it separately, or if I use some other color, maybe this. See, DF in circle of this triangle. DF. So if I draw a triangle here, let's say DF, and that's the end circle. Okay. Then see, you must be knowing the formula for in radius. I am just trying to tell you because I had to derive it while solving this question. So the derivation itself is very simple. Okay, let's say this is O, this is D, this is E, this is F. Now I just consider three triangles. That's it. So area of triangle DEF is equal to area of triangle DOE plus area of triangle DOF plus area of triangle EOF. See, in every one in right side, so this is, let's say, delta, the area of the triangle, delta DF, this is half times R, because altitude in all the three triangles, these three triangles are, and then its base, so half times DE plus EF plus DF, which is nothing but perimeter, hence so delta by S is equal to R. So that's how we can easily derive it. So this is semi perimeter, A plus B plus C by 2. Okay, so then you can get delta, whatever method you want to use it, you can use it and then find your this like in radius of this triangle. So that's it. The answer has to be in anything in between these two, that you can do it. Okay. So now moving to the next question, the equation this represents a pair of lines whose slopes are m and m square. Pair of lines whose slopes are m and m square. See, whenever we have to write, so observe here, the coefficient of y square is positive 1. Okay, so y minus m1x, so we are given slope, so why will I write m1? I will write mx, and then minus c1 equal to 0, y minus m square x minus c2 equal to 0, just multiply, and see, we have to just collect the terms because the all possible values of a. Okay, so multiply, coefficient of y square is 1, it's 1, coefficient of x square, coefficient of x square is m cube, and here it's a, that's 1, and then coefficient of x into y, so coefficient of x into y, so here it is minus 6, and what will that be here? So it's minus, this will multiply with this, so minus m plus m square. So m square plus m minus 6 equal to 0. So now we have it. So m is either minus 3 or m is 2. So ma is either minus 27 or a is 8. Add them and we have minus 19. So that's it. So that's the answer. So that's yet another, I think, the second or third question where I got the final answer, or I solved it till the final answer. Let ABC be a given isosceles triangle with AB is equal to AC. Sides AB and AC are extended. Okay, see, in this one, now of course I am doing it with my convenience. I mean, where I feel that I can't use geometry that much, because I tried to use geometry here. See, let me draw the figure, but I couldn't do it. See, then it's an isosceles triangle. Okay, so without losing any generality, you can easily assume your triangle to be in this form. So if I write it as minus b comma 0, this is b comma 0, and then this is 0 comma a. Okay, now where did I try? So what I actually looked here is something called similarity. I tried that, but then to be very true, I couldn't conclude anything from there. So then I used coordinate geometry, the line, the equation, whatever. See, AB is equal to AC, so I got BE by AB is equal to AC by CS. So I tried to look at it as some similarity type of thing, but I couldn't get anything substantial there. Okay, so then I went back and then see, this is something which gives us something here also. So BE, so you extend it till E and you extend it till F. Okay, now see, I'm telling you what to do because it's a very lengthy one. Okay, so get this point. How? Using section formula. We are given AB is to BE. Okay, so you can write AB is to BE. Okay, so B divides this and let this be lambda. Let this be lambda. And this point be x1 comma y1. Okay, so this is lambda AB is to BE. Rather, I think BE is to AB. I'm sorry, yeah. So it has to be in the reverse case. BE is to AB. So this is lambda is to 1. So apply this formula. So what is it? So if I go for, so minus B abscissa will be 1x1 plus 0 by 1 plus lambda. See, you got x1, and how much is it? So x1 is nothing but minus B times 1 plus lambda. Similarly for y1, if you go for y1, so it's 0. 0 is equal to, this is y1 plus a lambda, I'm sorry, y1 plus lambda, isn't that? So y1 is nothing but minus a lambda. So you got this point, which is minus b times 1 plus lambda, and then minus a lambda, and that's it. Similarly, you will get f. See, and then what you have to do? You have to just write this equation, because the question statement says that prove that it always passes through a fixed point. So any variable line, so if you have any like set of infinite many possible line, they all pass through a fixed point. You have to just prove that. You can write it as L1 plus lambda L2. Okay, so you have this point in terms of lambda, you will get this point in terms of lambda itself, because the ratio is same. AC is to CF or CF is to AC. The ratio is same. Okay, so you will get it in terms of this. So here, but here it will be C. AC is to CF, okay, which is lambda is to 1. So anyway, you will get F in terms of lambda. Get the equation of line using 2-point form, and lambda is the unknown, because lambda we don't know, that's not given to us, we have introduced it. Okay, so then collect the terms of lambda separately, rest of them separate, and you should and you must get something like this, and then you will conclude that the line passes through a fixed point. That's how you should try to do, that's how you should try to finish it up. Okay, I'm leaving it here because that's how I did. Again, I will say, if you have any better idea, do share it with me with the help of comments. The vertices of a triangle are this, this and this, where m and n are integers. If it's area, see, area of a triangle, so the simplest way is determinant form. So it's m and 1 2 19 1 and then 23 21, and this is equal to 70, of course with modulus, don't forget mod of it. Okay, remove mod, so it's nothing but if I and meanwhile if I solve it also, so 19 minus 20 is minus m minus n times 40 minus 3. I'm sorry, it will be a big number. 23 is into 460 and then 4 if I'm not wrong 437 bachcho, isn't that? And then with 1, okay, sorry, with n at least it's not that big a number, right? With n it will be 2 minus 23 is minus 21, yeah, and with 1 it will be 40 minus 437, and this is equal to plus minus 140. You get two relations here, which are that 21m minus m and minus 37 gone 397 is equal to, let's say, 141 and then 1 minus 140. And see, median, the slope of the median through A is, so that's not a big deal. Why? Because see, this is B, this is C, median is the midpoint, and that's the slope. You can easily get the midpoint, and the midpoint is nothing but B plus C, 23, 25 by 2, and then 39 by 2. So it's 25 by 2, 39 by 2. And A point is nothing but m comma n. So you have the slope. So slope is 39 minus 2n upon 25 minus 2m, and that is nothing but minus 5, if I'm not wrong. Yeah, it is. So then you have two equations, two unknowns. Solve this one. We'll see again. I will say that's how I solved it. I tried to think so many things, but I couldn't. That nothing helped here. I mean, not so many things. I tried to use few things, but nothing helped. I couldn't find any pattern. The numbers are a bit weird type of number. Okay, so that's how I solved it. So that's another question. Okay, then moving to the 11th one, triangle of ABC having vertices 5 1 minus 1 minus 7 4 respectively. Let L be the line mirror, yeah, passing through C and parallel to ABC. 5 1 minus 1 C 4 1 4. Passing through C, that's the mirror, and parallel to AB. Angle bisector A, meet it at E, and mirror at E and BC at D respectively. Okay, light ray emanating from a point along the direction of angle bisector of A if the sum of the areas of triangle ABCE and ABC. Okay, so 5 1 minus 1 minus 7, so this is 5 comma 1, this is minus 1 comma minus 7, and this is 5 comma 1 comma 4. That's our C. Now again, see, this is simple. If I have to get this point here, maybe that's D, of course, that's D. Okay, see, again, when I solved these two, so I got something, yeah, this distance, what is it? So I got it as 5, 8, 64, and then 36, that was 10, I think that was 5 if I'm not wrong. 4 and 3, yeah, that's 5. So that means we know angle bisector of any vertex angle divides the opposite side in the ratio of the arms forming the angle. Okay, so we shouldn't forget it, in the ratio of the arms forming the angle. So this is 2:1, so we'll get D. So let's write it. So it's 2 plus minus 1, so it's 1 by 3. I think it's 1 by 3 comma 1 by 3, and this is 8. Yeah, it's 1 by 3. You get it? Okay. Now see what do we? So though again, I tried few things here again because triangle ACE, that's the common base. I mean ACE and these two triangles are because this is parallel to that. So these two triangles are of equal area. Triangle ACE and triangle BCE, they are of equal area, but they have asked the relation between the sum of the area of ABC, which you can easily find using determinant form, and then area of triangle ACE. Then again you can easily find it. How? Because you know this equation of line. You know this equation of line. Solve it with this, because again you know this equation of line because it is parallel to this one. Okay, so equation of mirror line is which is parallel to AB and passing to C. You know it. Equation of AD you can write and then solve it with this line mirror, and then you have C point, and then you can find the area using determinant. Okay, though I observed that these two triangles have equal area, but it didn't help. Okay, anyhow, somehow. So I mean, to me, again, if you get something idea, then do tell me and do share it with me. The line joining the point of intersection of the curve and the point at the origin to the origin make angle with the positive x-axis. Okay, see, again, that's a simple direct question of homogenization. The line joining the points of intersection of the curve and the line. So let's say these are the points of intersection to the origin. Make angles with the positive x-axis, which are, so the sum of the slope. I mean, the sum of the slope is 90. So it's supplementary, the sum of the slope is complementary, sum of the slope is 180, it's supplementary. Okay, or m1 is equal to m1, m2, then it's, so again, you have to just homogenize it. So for that, x by 2 minus y by 2 is equal to 1. Fine. So if I have to homogenize, I will write it as 5 times x square plus 12xy. We won't disturb the second degree term, minus 4y times x by 2 minus y by 2 minus 8 times x by 2 minus y by 2 into x plus 12 times x minus y whole square by 4. Okay, so this is 4, this is 2, so it's 5x square plus 12xy minus 8y square, and then it's 2x minus 2xy plus 2y. See, now you people can easily do it. Of course, you could have done it earlier also, I know. 4xy, and then it's 3 here. So plus 3x square plus 3y square minus 6xy. Okay, get it? Fine. Now see, that's the angle between two lines, tan theta. So you may get tan theta directly from here. Or what you can do otherwise is, of course you can, you will get the line, and then see what you can do is, since that represents, because we don't need theta, we don't need angle between the lines, we need their individual slopes m1 and m2. So then I will suggest you minus c2 equal to 0. Okay, so now just solve it. So what will we get? Plus 8, so it's 4x square, and then 12xy, 4xy minus 8 is 4, 4, 8, 8xy. Okay, and then for y square minus 8y square minus 6y square, and then minus 3y square. 4, 3, 12, 6 to 12, but this minus, no, we can't factorize it. Okay, so once you get it and then you write it and compare. See, you don't have to solve it completely, you have to just compare the terms of x square, y square and x into y to get the relation between m1 and m2. Then from there you can get, you can just check it out. Okay, whether m1 plus m2 is something, or m1 minus m2 is something, whatever you have to do. Okay, so then you will get it. Achha, one more thing. It's supplementary or not, complementary or not. Complementary means if one angle is theta and there has to be 90 minus theta, so tan of theta is m1, so another one has to be cot theta. So that means the product of slope has to be 1. For supplementary means if one is theta, so one slope is tan theta, another one angle is 180 minus theta, slope will be minus tan theta. Tan of 180 minus theta is minus tan theta. Sum of the slope has to be 0. For this one, the sum of slope to be 0. For this one, product of the slope is to be 1. M1 is equal to m2. Makes sense? None of these. So when I solved, I got answer is none of these, nothing matches. Okay, we didn't get any very special relation for which we can say okay, the lines are some particular type. Okay, now moving to the ABC with the 3 points on the straight line. See, that's a very good question I found. I mean, very good. Why? Because see, I could think something which helped us to solve it so quickly. B is a line between A and C. Consider all circles passing through B and C. So how many circles we have passing to 2 points? We have infinite circles passing to 2 points. Okay, then the point of contact of tangents from A on these circle lie on. So we have to find the locus of these points of intersection. Fine. Now see, if I just consider this circle. Remember the theorem. The theorem says if you draw a triangle from an external point to the circle, then AP, its length, is AB into AC. Now since these 3 points are fixed, so this is fixed, we are done. So that means distance of this variable point S comma K from the fixed point A is a fixed value. The distance is a constant. So hence the locus of point P is a circle. So when I realized that we can solve it like this, so I just shared this question again with you people. Okay, just to discuss this theorem and how to use it in this question. Okay, so that's really a simple question without using any calculation, any algebra, any coordinate geometry. A line passing through this one comes the slope of the line for which the intercept between this and this subtends a right angle at the origin is C. Here again, what I did, I use homogenization. We use homogenization for a second degree curve. Now, if I write the combined equation, so that means if I write x minus y minus 2 equal to 0, and then it's minus x minus y plus 2 equal to 0. So maybe y minus x minus 2 equal to 0, and y plus x minus 2 equal to 0, right? So if you have to combine it, so it's y square minus x minus 2 whole square equal to 0. So it's x square y square minus x square, and then it's plus 4x minus 4 equal to 0. So now just homogenize the slope of the line with this, which equation? So equation of this line passing to 1 comma 0 with slope m is y minus 0 is equal to m times x minus 1. So y by m minus x is equal to minus 1, so 1 is equal to x minus y by m. That's it. Just homogenize it. So no change here. Minus x plus 4x into x minus y by m minus 4 into x minus y by m whole square equal to 0. Homogenize and get angle between the line, because this represents the angle with that intercept subtends at the origin. Okay, the intercept subtend. You see, if you go with the curve, so I didn't draw the curve here though I normally don't miss it. So that's the intercept, okay, which has to subtend some angle at the origin. So I considered these two lines as the combined equation, as a second degree equation, second degree curve, and that's the chord. So chord subtending some angle at the origin. So that's what I use, and hence I use homogenization here. Okay. Now moving to the last question, and consider 2 points A and B. So A is minus 3 comma 0 and B is 0 comma 4. A is minus 3 comma 0 and B is 0 comma 4. So these are two points. If a point P lie on the line, this is 6 and then this is minus 4. Okay, so it lie on 6 and minus 4, so something like this. So that's the line 2x minus 3y is equal to 12. Okay, so let's say point P lie somewhere here. So you have to find the maximum value of, so we have to find PA minus PB maximum. Now remember, in a triangle, so if we talk about a triangle, triangle APB, difference of two sides, so PA minus PB, so difference has to be positive, so more difference of two sides is always less than equal to the third side. So the maximum value could be AB, but then when does this equality hold? This equality hold when APB are collinear. So that's it, we got it. So what does that mean? So they have to be collinear. So draw a line and the point where it meets this line. So you have to just write its equation, and since we have intercept x minus y, x by minus 3y by 4 equal to 1. So it's 4x minus 3y minus 4x plus 3y is equal to 12. That's it. And solve this equation. With this equation you get the point, and since I did it, I got it as 6, 0, so that should be the answer. So that's the last question of this worksheet. Now in the next one I will be uploading 2 worksheets of mains level 10 questions in solve circle, because when I was selecting questions I got pretty good questions there. Okay, so I just distributed it into 2 worksheets of 10 questions each, and then as I told you earlier, it will be followed by integration, the 12th class portion, the complete integral calculus including area, differential equation, and then to vector, 3D geometry, probability, and then we will come back to algebra part and the remaining conic section here. So that's it for today. Do subscribe the channel if this series is helpful to you people, and of course like the video and share it if it's helpful, and if you wish to do it. With all the best wishes, we'll meet in the next one.